Hi, this is a recorded lecture for the IB DP Design Technology, topic A3.2, Structural Systems. This is the HL content, and we're going to really focus today on support beams and columns. So let's start with the very simplest support beams. These are simply supported beams, a beam that is supported at either end. You can see that in this drawing here. We've got our beam, and then we've got supports at either end. And they function to carry vertical loads like a roof or a floor across a span. A wooden plank placed over two sawhorses might be an example, a bridge deck resting on its piers, or simply a lintel above a door or a window opening. A fixed beam is a member in a structure that is fixed on both ends to supports. So here's the beam, and here are the fixed ends, and these are the supports also, these fixed ends. Fixed beams are ideal for situations that require greater strength and resistance to bending or deflection. Examples could be the frame of a building where the beams are rigidly connected to the columns, or a concrete slab that is poured monolithically with the supporting walls. We have cantilever beams. This is a rigid structure that is fixed on one end and extends horizontally without support on the other end. So cantilevers are used to create overhangs and canopies where there is no support on the outer end. An example of this could be a balcony extending from a building, a diving board, the arm of a crane, or a traffic light pole. Continuously supported beams. This is a beam that is supported at more than 2 points along its length. This design is very efficient for long spans because it reduces the bending moment and the deflection compared to the single long simply supported beams. Some examples would be the deck of a multi-span bridge supported by a series of piers, or a long floor beam in the building that is supported by a series of columns. We have struts. A strut is a beam forming part of a framework designed to resist compression and support other beams. So you can see the strut here. We have a beam, it's attached to a column, and it's supporting this beam. Struts help transfer loads away from the weaker areas and distribute force more evenly. In a bridge or a roof truss, struts support long spans and prevent sagging or buckling. And essentially what you're seeing here is struts form triangles. And remember that triangles are quite hard to deform as opposed to right angles or squares. We have columns, and columns are upright pillars typically used to support beams in structures. So we've got these columns right here. These are what we typically think of as columns. And of course, this would be a beam up here. So this is a continuously supported beam because we have more than two columns. So columns are compression members that prevent the structure from collapsing under vertical loads. Examples could be pillars supporting a temple, which is what you're seeing right here, the vertical concrete or steel members in a high-rise building, or the piers of a bridge. Thank you for watching.